Yeah, just make lots of references to the meeting we've been having.
Okay.
Remember 10 minutes
We have
ago?
been having it for an hour, so.
Yeah, we have.
Okay.
Okay, we're rolling now.
Okay, good.
I'll
Thank
tell
you.
him
Which hypothesis involves equality?
the null.
The true hypothesis. Just kidding.
It's the null, just because the alternative hypothesis is never equal, right?
Either not equal or greater or less than.
Okay. Going null. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, this do you assume to be true? No.
The null.
No, you would assume to be true, yeah.
Suppose the null hypothesis is the mean is 10. Mean equals 10. Use this information for the next 3 questions. Which of the following represents an alternative hypothesis for a two-tailed test?
That would be the alternative hypothesis of the mean does not equal 10.
Right on. Which of the following represents the alternative hypothesis for a left-tailed test?
A.
Mean is less than 10, right?
Mm-hmm.
Is that the one you guys said?
Yep, that's what I got. Then the next one for the right-tailed test would be greater than.
Mm-hmm.
Yeah. Okay, this isn't too bad so far. Remember, we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to answer the next 2 questions. This relationship would result in failing to reject the null hypothesis.
I think it would be, isn't it the p-value is greater than the alpha?
Yeah.
Yeah, I think you're right.
Because if it's less than, we can reject it, but if it's not, then we can't. Because it'd be more extreme than the result we did find earlier.
The next one would be less than. Right?
Yeah.
P-value is less than. Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was about $1,500. They are concerned that the true mean is actually higher than this. Use the information for the next 2 questions. Which of the following would be an appropriate alternative hypothesis?
The average claim amount is greater than 1,500.
I agree.
Yeah, because they believe it's higher. Yeah.
Which of the following would be the appropriate null hypothesis? A.
The amount equals 1,500, right?
Yeah.
Yes. The insurance company randomly selects 40 claims and calculates the sample mean of 1,650. Use this information to answer the next 3 questions. The insurance company assumes the distribution of sample means is normal. Is this a good assumption?
Yes, it is.
Yeah.
Because the sample size is large. Right?
Yeah.
Yes.
Excuse me.
What theorem or law justifies your answer to the previous question? Central limit theorem, right?
Yes.
Mm-hmm.
Yeah, because isn't it dealing with the mean?
Yeah.
I always mix up those two. Those two drive me crazy.
Oh, I read it wrong. The insurance company assumes the distribution of the sample mean is normal. The distribution is normal. Okay. If it says distribution, I go with central limit theorem.
Mm-hmm.
Okay.
But we all know that I get that one wrong a lot. So
I think you're right.
Gotta watch Bruce on the central limit theorem.
yeah, I really have no idea what those are. That's probably what I got wrong on the test.
Those two, I always mix up those two. It drives me crazy. I hate those two.
Okay, I'm guessing central limit theorem. I won't be mad at you if you don't.
I'm gonna go with it.
Okay. Which of the following is a test statistic as defined in this lesson?
That'd be
Huh?
bar X, right?
Is it?
I don't know.
I don't
Not N, it's not Z.
think so.
Then S is a standard deviation.
What? Isn't N just the what's it called? It's the unknown.
N is
Yeah.
N's the sample size.
Yeah. So
X is the sample mean. X bar.
mhm.
In the textbook, it says that Z is the test statistic.
Oh, duh, because we just did that thing. It's like, what's the formula for the test statistic?
Oh, Z score.
Gosh, Z-score.
Oh, and then you find the p-value of the Z score.
Mhm.
Or
Yep.
the test. You find the p-value of the test statistic. Okay.
Yeah.
Another word, fancy way to say the Z-score. Okay.
Thanks for that.
Sweet, thanks, Matt.
Good save. Historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects the average has decreased. She sets up a hypothesis test with the hypothesis. The null is the mean equals 150, and her test hypothesis is the mean is less than 150. She will use a level of significance of 5%. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals 144. Use this information for the next 4 questions. What is the Z-score associated with this test? Well, -44 minus 50. What's the standard deviation? 40.
40.
$40. Did anyone else get a negative 0.09 or negative 0.9?
Yeah. That's what I got.
Yeah, that's what I got. -0.9. Okay. What is the p-value associated with the Z-score from the previous question? So that's just the tail less than 0.9, right?
Yes.
So you don't have their applet up?
Yep, I do. I actually tested it already, and the area, it's what he said, it was 0.184. What Philip said. Basically, yeah, you just plug in the Z-score into the applet, highlight the left tail, and you get your probability, 0.184.
Cool. What inference would you make about the null hypothesis for this problem? Fail to reject, right?
Yes.
Yes.
Because our p-value is 18.5% and profit is 5%.
Yes. So it's larger, so it would fail to reject.
What is your conclusion for this problem? Oh, this is the tricky one.
That does make sense. If we have insufficient evidence that the true population mean is less than 150, which basically means, yeah, we can't prove that it's less than 150.
Perfect. By T, there are two types of errors that can be made in performing a hypothesis test. Which one involves rejecting the null hypothesis when the hypothesis is true? Type 1.
Is it type 1?
Mm-hmm.
I think
Yeah.
it's type 1.
Yeah, that's because, yeah, you fail, well, you reject the null, but it was actually true. That's a type 1.
A researcher decided that instead of using a level of significance of 5%, he will use 1%. Which of the following will be true?
His
Probably.
type 2 will increase, right?
Mm-hmm.
He decreased his level of significance.
Which means the chance of type 2 increases. Mm-hmm.
So
Okay.
to see if I'm looking at this correctly, maybe you guys can run it by and make sure I'm doing it. So when I see an alpha value of 0.05, I look at that as there's a 5% chance I can make a type 1 error. And then that means I have a 95% chance of making a type 2 error. And then looking at that, he says, well, I'm going to change it now to 1%. So now my type 1 error likelihood is only 1. But then my type 2 error went up to 99%.
I think that's a good way to look at it.
Mm-hmm.
I just want to make sure that was actually jiving, like it was actually right.
Yeah.
I think it's right.
I guess we'll see in a few seconds.
It's right. Okay. And then this one's just the same thing. 0.05.
I think so.
Cool.
I'll submit real quick and see. Moment of truth. %.
Nice.
Yes. So yeah, so that is a good way to look at it. That is an easy way now to know how for type 1 and type 2 errors.
Mhm.
Alpha value is type 1 error.
Yes.
All you gotta remember.
All you gotta remember, whatever your alpha is, that's the likelihood you can create a type 1 error.
Yes.
Okay. Well, this has been fun.
See you on
I will see you
Tuesday.
guys on Tuesday.
See you Tuesday. You probably post a note and say, we actually did meet. We just didn't start recording until we did our quiz. Sorry.
I will.
Thanks.
Promise that.